Hi guys, we're going to do a problem where we find the greatest coefficient of a binomial expansion, and we'll do that by using the binomial theorem. Enough said. Enjoy. Bye. So we're going to find the greatest coefficient in the binomial expansion, 2x plus 5 all to the power of 15. What does that mean? Well, the expansion will be our expression in terms of powers of x with numbers in front of those x's. So the numbers in front of the x's are the coefficients. So we're going to find the greatest one, okay? To do that, we're going to find ck, the kth coefficient. And once we've got an expression for the kth coefficient, we're going to solve this expression here, which gives us a sequence of increasing coefficients, and thereby we can conclude which one is the greatest. Simple. So we'll end up solving this expression here, ck plus 1 over ck is greater than 1. We don't need to worry about negatives because they're obviously all positive. We're going to need the binomial theorem, which is for a plus b all to the n. That's equal to the sum from 0 to n of n choose k, a to the k, b to the n minus k, where the binomial coefficient is that. Okay, so the general coefficient for ax plus b to the n, which is what our question is about, is going to be nk, ak, bn minus k. We didn't put an x in there because we just want the coefficient. If we wanted to actually have the general term, you put an x to the k in there as well, and that's relevant for some questions, but not for us. ck plus 1, then you just use that one and plug in k plus 1 everywhere. We're going to find the ratio. That looks pretty mind-boggling, but that's okay. This part here will simplify very nicely, and we'll do that separately just here. If you plug in all the expressions here for the formula for the nck or the n choose k formula here, you'll get that. And you have to be fairly good at algebra to make this work. You flick it around algebra-wise in terms of fractions. There's lots of cancellation, and we used here the fact that n minus k factorial is n minus k times n minus k minus 1 factorial. So you walk it down 1, and you walk this one down 1 too. When you walk them down 1, there's cancellation, and you end up with just n minus k over k plus 1. And that grossly simplifies our coefficient ratio. So this becomes n minus k over k plus 1. Now we just have to deal with the indices here. And you again have to be good at your algebra. But there's lots of cancellation. Pretty much everything cancels except there's an a to the 1 and b to the minus 1 that survives. And so you end up with this. And that is the formula most people memorize. But I don't like memorizing. I like to rederive it every now and then because sometimes they get the a and b mixed up and you get your question wrong. So it's up to you though. All right, so let's do it for our question. Put a equal 2, b equals 3, n equals 15. Solve it for greater than 1. Linear inequality. Read it the other way. So you get k must be less than 5.4. So what that means is that ck is less than ck plus 1 if k is less than 5.4. And that translates into c0 or c0 is less than c1 is less than c2. For example, up here, if you put k equal to 0, you would get c0 is less than c1. So that takes care of the first one. So if you put k equal to 5, it's c5 less than c6. So that'll be the last one. So that's the sequence generated from that. And for free, you flick it around, you get the other one. And you put them together, you got this one. So you can see that I like the visual on this and writing it all in one go. You don't have to do that, but sometimes you get the middle coefficients being equal, so there's a little ambiguity there. In this case, there's just one highest coefficient. You plug the numbers in for that, and you get this great big number. I won't read it out, but you could see it, right? All right, there you go. Hope that was fun. Have a great day, guys. Don't forget to click like and show me some love. Bye now.